Hi everyone, let's try to solve this problem. Construct a binary tree from Inorder and Postorder traversal. So we are given the Inorder and Postorder traversal of a binary tree, and given these two arrays we have to construct a tree from it. So I've written down the test case here. Now we know that in Inorder we first visit the left child, we do a left of root, and then we print the root node, and then we go to the right child. Okay, this is for Inorder. For Postorder, what do we know? We know that we go to the left, then we go to the right, and then we print the value. Okay, so basically we're visiting all the nodes in the left, all the nodes in the right, and then we are printing the value. So the last node of it, it's definitely going to be the root node, right? Because we have exhausted all the left side subtrees, all the right side subtrees, and then we're printing the value. So let's just try to form a logic on how we can construct this tree given the Postorder and Inorder. Here if we see, right, we have 3 is going to be the root of the it's going to be root of the tree, and it's always going to, the root of the element is always going to be the last element in the Postorder traversal. Okay, and what do we know? We know that if we see this, right, we can see that if we go to 3 here, all the elements to the left side of it are going to be located in the left subtree, and all the elements on the right of it are going to be located in the right subtree, because we visit the left, then we print the node, and then we visit the right. So here if we see, right, the possibilities of values in this tree can only be 9 here, and the possibilities of all the values in the right tree can be 15, 20 and 7. Okay, and now let's go, this is done, suppose this is done. Now let's go to this element, okay, 20. So the root node, which is 3 dot right, is going to be whatever next element we have. So 20, suppose it's 20, it's going to be 20 here. And if we make this as 20, right, what should be its left values? Its left values are now only going to be limited to this, right, because previously we exhausted the list to here. So all the elements to the left side of it can be 15, and all the elements to the right side of it can be 7. Similarly, here at 9, what can we do is, let's construct a tree here. 3 dot left is equal to 9, and then the left values is going to be everything here, which is going to be 0, null. Everything here, which is again, here there was only one element, right, everything to the right side of this is also going to be null. So that will be our base case. So basically, how are we going to construct a tree? We're always going to iterate this Postorder in a reverse direction. So, and whatever value we get, right, we're going to construct a node out of it, and this dot left is going to be equal to whatever values you can get from the Inorder. So initially what are we going to do? Inorder of Inorder mein let's pass 0 comma n minus 1, because all these values are possible. Then what are we going to do? If start, because in all these null cases what's going to happen is this start is going to be greater than end. In this case we're going to return null. Otherwise what are we going to do? Val is going to be whatever element is there in Postorder. We're going to construct a tree from this, and then we're going to do n dot left is going to be equal to, we have to find the index of this in the Inorder tree. Say it's idx, then we have to call the function again for now Inorder dot right, because here we can see that the next element is going to be the right of the subtree. Inorder dot right is going to be idx plus 1 and the same end, and n dot left is going to be construct tree start comma idx minus 1. At the end we return n. Okay, and now we have to find index. One way to find the index of a value in a tree, right, here we are given in the conditions that each it contains all unique values itself. The tree will contain unique values. one thing is we can do a binary search, right? So suppose I have to find 3. What is the index of 3 in the array? We can do a binary search. But every time we construct an element, we have to find the index of that element. So we are going to be calling binary search n times. So that itself is going to be n log n. So instead of that, we can just store the indexes of each element. The indexes of each element in a hash map, and we can use that hash map to find the index of a particular element. So I hope the logic is clear. Let's try to write out the code. Okay, so I'm going to be using Inorder and Postorder outside of this method as well. So let me just create arrays for the same. Okay, let me have an int idx, which is our initial thing, and let me have an int n, and then let me have an hash map. This is the val index in Inorder hash map. Okay, now I'm going to just set the values. Okay, and then I'm going to do, initially it's going to be n minus 1. So let me calculate n first. It's Inorder or Postorder dot length. It's going to be the same anyways. And now let me just populate our hash map. So what am I going to do? I'm going to do val idx Inorder dot put. I'm going to put the value, which is going to be in order of I, and the index is present, which is I. And at the end, let me return. I'm going to have a function called construct tree, and here I'm going to pass 0, n minus 1. Okay, so now let me write the function. Tree node construct tree, and here I'm going to have values and start int end. Okay, now if start is greater than end, I'm going to return null, else int val is going to be equal to post order of idx. Then we are going to have idx minus minus, and then let me create a tree node for that element, and that is going to have a value of val, and then we have to populate the left and right subtrees, and this is just going to be construct tree. And now I basically have to find the new index, right? So int new index is going, it's not really new index, but it's basically the index where it's present in the Inorder traversal. It's going to be, what is it, hash map val idx Inorder dot get val, and now construct, we first have to construct the right subtree, right? Construct tree, and here we're going to pass the start itself. No, we're going to construct the right subtree, so it's going to be idx plus 1, end, and here it's going to be On the left side is going to be start comma idx minus 1. At the end we just have to return the node. So let's see if this works. idx is equal to n minus 1. Let's try to debug this, and I'm going to get the value from here, and then just give me a second. And then we're doing idx minus minus, that's fine. And next time the value is still going to be this. Oh, here I'm not using the correct idx, I have to use Inorder. Now let's try to run it. Yep, now let's submit it and see if it works out. Yep, looks like it succeeded. Now let's try to find the time complexity. So basically to do this, we're iterating through each element only once. So the time complexity is going to be O of n. And when you consider space complexity, the space complexity is also going to be O of n, because internally we're using a stack, and as well as that we're going to use a hash map to store all the elements, right? So it's going to be O of 2n, which we can consider as O of n. So I hope this is understandable. Thanks everyone for tuning in. Bye bye.